Cool. It's the 25th of April, 2025. We're in a small town called Vosloorus in South Africa. We're in a busy clinic. The nurse has a lot of patients to see. She's seeing a patient every 15 minutes. One of those patients rocks up with a headache and a high blood pressure. The nurse doesn't think too much of it, prescribes a couple of Banados, sends them home to rest. You're thinking, what does this have to do with Google Cloud and being a developer? Well, the use of data engineering, data science, a little sprinkling of AI and Google Cloud allows us to flag that as a potential missed emergency. Because see, presenting with a headache and a high blood pressure could lead to brain bleeding. And our platform we've built has empowered us to deploy models like emergency flaggers that can be deployed in healthcare sectors and pick up potential emergencies like this to be investigated further. So today, myself and Dr. Hamza Van Der Ross will speak about empowering healthcare with Google Cloud. Cool, so to introduce ourselves, I'm Ulrich Kotze. I'm the technical director at Wimmy. We're a data science consultancy based in Cape Town. We specialize in healthcare. If you want to learn a bit more about us, you're welcome to scan the QR code.
Sure. My name is Hamza Van Der Ross. I'm a medical doctor with a master's in data science.
Cool. So on the agenda today, so we're going to start with a bit of a healthcare context. So Hamza is just going to speak a bit about healthcare in general. What does the data look like? What are the challenges we're facing? Then we'll move into a case study. So I don't want this talk to be fiction. I want it to be real. I want to show you what we've actually built, what we've actually deployed. We'll take a look at the platform, the decisions we had to make for our platform, given the constraints and the situation we're looking at for our client and the healthcare sector in general. We'll do a bit of dreaming. We'll look at Gen AI in healthcare. We'll look at the picture we're seeing, given our constraints, given the tools available to us, and the decisions we need to make moving forward to integrate generative AI into our platforms and build for our clients. And then at the end, we can do some questions and a discussion. Cool, so over to Hamza.
Sure, thank you very much, Ulrich. So just going back to the story that you shared, the story, even though it shows what could have been a missed emergency, it does show in a small way the importance of data, the importance of sharing the right information to the right person at the right time. However, doing this within a healthcare context can be very challenging for many reasons. So before we go into the exact specifics of the use case, we'll just take a step backwards and look at the context and some of the systemic challenges that we face within the healthcare industry and its data landscape. One of the first issues is the fragmentation of the systems. You might have a clinical record system which is separate from a lab system, which is separate from a radiology system. Even sensor data, which is often completely separate from the patient from which that was taken. There's also inconsistent adoption of data standards. So there's multiple ways of classifying information within the healthcare setting. Billing, diagnosis, all of these different things, even the ways in which electronic health record systems are structured. This is a barrier to data interoperability. Also, poor usability. Because clinicians have a heavy documentation requirement, it's very important to make sure that the UX integrates well within the workflow system. Also, within the healthcare system, there's the issue of stakeholder disagreement. The reasons for a patient wanting their information to be collected might be different from the reasons that a clinician might want to collect information, which might be different from the reasons why a facility might want to collect information. All of these lead to many disagreements with what data should be captured and why. This leads us to the issue of data privacy and governance. So in South Africa, we currently have the POPI Act, which is based on GDPR. This helps us decide what the data should be used for, what constitutes the proper processing of this data. And the last thing is data quality. So there's often free text fields, data is often messy and unstructured, and there's also the issue of data completeness. And these things might be a barrier to analytics and might not meet the standards for what we need, even for predictive modeling. All being said, this kind of sets the stage for the context in which we are working.
Thanks. Okay, so we're going to move forward and look at a case study. So thanks to Unjani Clinics for allowing us to share just a little bit of context for to lay the stage and to share the scene we were looking at. So Unjani Clinics is a non-profit organization based in South Africa. They provide private healthcare. They have about 280 clinics spread across the entire country. So if you see the map there, that's the real map of where the clinics are. So they're quite heavily based in Gauteng. There will be quite a few opening up in the Western Cape soon, hopefully. So you might be seeing them pop up here and there. They have 2 million patients. They see about 150,000 patients per month. And they have a goal of reaching 600 clinics by 2030. So more than doubling in the next 4.5 years. On average, a nurse sees a patient every 15 minutes in this network, which is a lot. And that's a lot of work that needs to happen in a very short amount of time. So that's set to scene. There's a picture of us at an Unjani Clinics. That's Sister Molly. This was in Gauteng. It's a picture of our team at one of the clinics, and there's Hamza also there. Cool. So if we look at the business requirements of this case study, so Unjani wants to democratize data within the organization. It's become too big to just run on intuition. There are too many settings across the country. There are too many people involved to make decisions purely just on gut feel and intuition. They want to make decisions based on data, based on facts. And ultimately, these decisions are for the betterment of the care to the patients, for the nurses, and for the network as a whole. So what they want to do is foster data-driven decision-making across the organization. They need insights from the data. So the EHR primarily, so that's the electronic health record system, is the primary source of data, but there are other sources of data as well. I mean, it's not just clinics, it's a business as well that has marketing, it has finance, and so forth. So we're looking at social media, finance data, marketing data, and the insights need to happen at various levels, right? There's macro insights, so at a network level, how is the network performing? But also at a micro level, so the patient, how is the patient doing? And the nurse, how is her clinic doing? And we need to be able to look at the data at all of these different levels. The other part that's also really important for Unjani is they're a disruptor. They challenge the norm, and they often have pilots that they want to run. They want to test new AI tools. They want to test a new screening tool. And the platform we build needs to be able to adapt to this. So we need to be able to do rapid prototyping and evaluation of tools. That's a really important consideration to make as part of building the platform. Cool. So that was the business requirements. I mean, we're technical people, so we have to map that onto platform requirements, right? So what does that mean for us? It means we need to be able to handle big data. I mean, 150,000 consultations a month. We have an EHR with 100 plus tables and gigs and gigs and gigs and gigs of data. We have a bunch of other data sources, and they have the goal of doubling the network in the next 5 years. That means the volume, velocity of the data is going to scale over time, and it's going to keep growing. And the platform we build needs to be able to handle this. So for us, reporting and analytics is a starting point. So data transformations, prepared layers are things that are going to be extremely important. Some people would call it a curated layer, but essentially transforming this maze of raw data that looks like absolute gibberish if you don't know how to work with it, transforming that into data sets we can work with, data sets we can present to the exco who need to make decisions, and present to nurses who need to make decisions about their clinics. Cool, so that's two important considerations. The third one is we need to build a modular and flexible platform to handle diverse data apps and integrations. So I spoke about the pilots. These pilots often end up working, and we need to integrate this into the platform. So the platform needs to be able to handle these diverse data apps that they want to implement into the network. And this is a bit more us looking at this platform, looking at the future, seeing where data and AI is going. We need to be able to incorporate machine learning and AI as the maturity of the platform increases. Cool, and then the last one, which is very, very important, cost optimization is extremely important. So we're dealing with a client who doesn't have a full-time data team. They don't have 10 DevOps engineers who are maintaining the platform. And the cost of building the platform is going to make its way back to the patient. And the patient is the most important person. So cost optimization in building this platform is really important. And you'll see as we do the talk, a lot of the decisions we make end up focusing on cost optimization. Cool, so moving on to the actual platform, what we've built. We'll start with the cornerstones. So the kind of important considerations for us as a team, for the client, for the platform. Speed. So reducing the time from code commit to production is really important. It can't take months and months and months to deploy a pipeline. That's not good enough. It needs to be fast. If we're going to do rapid prototyping and rapid testing of new pilots, we need to be able to deploy it fast. Second thing is repeatability. So using standardized tools. That means every time there's a new pipeline or a new tool we're building, we don't want to rewrite the entire thing. We want to reuse code. We want to copy and paste and control F, and there it goes. There's your next pipeline that goes live. That's an important consideration for us as a team. Simplicity, very important. Ensuring the ease of use and understanding. So I think as engineers and data scientists, we revel in complexity. We love building complicated, complex systems and solutions. But for us, we said, no, we want to build simple things that's easy to understand, it's easy to use. I mean, Hamza came from being a doctor, and he's now deploying pipelines like he's done it forever. But that's because we've built a simple system. And that was one of our core principles. Last one is version control. I think that's always, always, always important. You need to track every single change we make to our code, to our pipelines. Super, super, super important. Cool, so moving into the actual technology choices. So the Google products that we are using for our platform. Number one is BigQuery. So we're using BigQuery for our data storage and preparation. So we'll go a little bit deeper into each one now after this. Second tool we're using is technically a part of BigQuery, but I think it deserves its own spot, is Dataform for also a bit of data preparation, metadata management, and data cataloging. Third tool is Cloud Run, which we're using for our compute. Cloud Scheduler. When using batch jobs, we use Cloud Scheduler as a managed cron job tool. And then Looker Studio for our data visualizations. Cloud Build and Artifact Registry for our CI/CD deployments. And then lastly, an honorable mention to the non-Google tools, GitLab, Docker, and Python, which is the glue keeping everything together, always important. And good to mention here, these are some of the other tools we are using in between everything else. Cool, so maybe just a bit of a focus on BigQuery itself. So I have once again, I have BigQuery and Dataform together because technically they are the same thing, but like I said, they deserve their own slides. So BigQuery is powerful for analytical queries. So like I said, we have an extremely complex EHR. It's a maze of tables to navigate. They need to be joined together. So extremely important. We need horsepower. And BigQuery has plenty. It can handle petabytes of data. So it's more than we need, and it will be more than enough as the data scales. But more important than that, the fact that we don't have to manage infrastructure or provision infrastructure for us was really important. The fact that we don't need a team to manage servers and constantly monitor our infrastructure, that was a very important consideration for us to make in choosing this as a tool. It has a pay-as-you-go model. So if you're not using it, you're not paying that much. You're not paying for servers to be on and while you're not using it. And then, like I said, the cost optimization is extremely important. So BigQuery has a very generous free tier. So you get 10 gigs of free storage per month, which is very, very handy. And you get 1 terabyte of data processed for free per month. I think for the first year, we basically weren't even paying for BigQuery. It was just for free, which is amazing. It goes a long way, especially for small to medium scale use cases like ours. It's not petabytes of data, it's gigs, and it might scale to terabytes. So it's not insanely large. So at that scale, it's extremely cost efficient. And if the pricing becomes an issue, we can always just implement quotas to have a handbrake on if things get out of control. Because you can build up a big bill if you're not careful. But if you know what you're doing and you have the necessary quotas in place, it shouldn't be a problem. Cool. So next up is Dataform. So Dataform is a bit of a newer tool we've started using in the last while. It allows us to build prepared layers. So in our time at Wimmy, we've built prepared layers in a bunch of different ways. I mean, we've had Airflow, we've had scheduled queries, we've had views. We've tried all kinds of, we've even built our own custom pipeline that kicks off prepared layers. We've tried it all. Everything has its drawback. Everything has its advantages. Dataform to us feels like the perfect midway between having an easy to use tool, but also have version control. Have your code versioned in Git. It has custom scheduling. It has dependency management. And the one I really, really love is the data quality rules, assertions. Within your prepared layers is super, super handy. And then the metadata management. I think we're in an era of AI. I'm seeing Gemini pop up in my BigQuery every now and then, suggesting stuff, wanting to give me column descriptions. But I think to empower AI in the future, I think the unsexy things is going to be important. I think metadata management, data catalogs, having really good data governance will be important. I mean, if you want an agent to operate in your database, I mean, it needs to know where to look. It needs to know what things mean. So for us, we see Dataform as a really important component moving forward. And once again, touching back on costs, it's free. It's just a free tool inside of BigQuery. It's kind of free. You still pay for all the compute you're using. It is running queries in the background, so you do pay for that. But except for that, it's free, which is amazing. Some of the alternatives we have considered is dbt. So this is basically Google's flavor of dbt. Airflow, scheduled queries, views, custom pipelines. We've tried it all, and we've settled on Dataform as our tool of choice. Cool. Then next up is Cloud Run. Once again, no need to manage infrastructure. Really important for us. Like I said, we don't have a DevOps team who's sitting in the back office managing infrastructure. That doesn't exist. So Cloud Run allows us to not worry about that. It's managed for us. It's not opinionated, which means it can run anything as long as it's in a Docker container, which for us is very nice. It means it's extremely flexible. It supports any language, framework, library. We've had all kinds of stuff in there, and it runs it all. Cool. And then this kind of touches on the prototyping I mentioned earlier. Cloud Run is versatile. We started with batch jobs. That was kind of where we started. That was the need at the time. Since then, we've moved to using Cloud Run services as well. So deploying backends, front ends, all kinds of stuff. Cloud Run can handle all of that, and it's scaled quite well. It's cost effective at small to medium scales, in my opinion. I think Gemini will tell you it's cost effective at large scales as well, but I'm yet to see that. So for the moment, for our use cases, it's more than good enough. It's scaling really well, and it's been really, really easy to use, which is very important. It's an extremely simple tool to use. Hamza's going to demo some of the Gen AI stuff. It took us 15 minutes to deploy a model to Cloud Run. It's really, really simple. It's really easy. And then lastly, your build for the CPU time and memory you use. So if it's off, you're not paying. At night, no one's at a clinic. We're not paying for any compute, which is great. So some of the alternatives we looked at is App Engine. Once again, it's quite a similar tool, but it's a bit more opinionated. And then Compute Engine, of course, we've had to switch to Compute Engine quite a few, well, not quite a few times, just once, when Cloud Run couldn't scale enough. That was for another client. We just switched our Docker containers to run on Compute Engine, and that was quite a simple switch. So that is also an alternative that we considered. But for this platform, Cloud Run has been more than enough, and it's been extremely cost efficient and easy to use. Cool. Then lastly is Looker Studio. My least favorite part of the Google stack, I must say. There's a free version available, which makes it really nice. Like for us, it's cost efficient. We're not paying for a BI tool. It's free. It's solid. It does the basics. It's a little bit limited in some senses. I have very often been asked to add something and had to say that's not possible. But it is being updated. It's being improved. They upgraded the look and feel quite recently, which is nice. But for us, it's the first thing that's going to be upgraded as the stack evolves. So other things we're looking at are tools like Metabase, Superset, a bit more open source. So there is a paid version of this available, which we haven't used yet. But for us, it being free is amazing. And yeah, really, I think I want to say good value for money, but good value for no money. So that's Looker Studio. So just to look at the architecture, so what does this kind of actually look like if we're deploying a batch container? So there are some other stuff in there, but this is a simplified version of what the architecture would actually look like. So of course, it all starts in GitLab. We deploy all of our pipelines using CI/CD. So our build step will use Cloud Build to build a container and push it to Artifact Registry. These are all quite simple and easy to integrate with GitLab. From there, our deployment step deploys the Docker container to Cloud Run. It deploys the Cloud Run job, linking it to the Docker container in the Artifact Registry. And then our cron jobs are just deployed to Cloud Scheduler. Once again, very simple. It's one line of code in your CI/CD pipeline, and that Cloud Scheduler is linked to your Cloud Run job, and your jobs are kicked off to run on your schedule. Cool. From there, data is moved to BigQuery. So we tend to have a raw layer where all of the unprocessed, unfiltered, untouched data lands. From there, you'll see a data form step. So this is the really important one. The data form step, you'll see it's connected to GitLab via Secret Manager. So this is how the version control works. Really nice. So all of our transformations in data form is version controlled. And we can see who changed what when Hamza merged the code that broke. Cool. So that's data form. From there, the data moves to our prepared layers. And ultimately, the Looker Studio dashboards are reading from prepared layers to visualize our curated data sets. Cool. And then to move to backend, it's just more of the same. It's essentially the same. It's the same pipeline. It's the same code. There's maybe 1 or 2 lines of code that changes to change your deployment pipeline from a job to a backend service. Same for front end, same principle. Code is essentially the same. Maybe a tweak here or there. And for us, this has been a game changer to move between batch jobs, back end, front end. It's all the same code. It all works similarly. We can all understand it. If you can deploy a batch job, you can deploy a front end. It's the same thing, and it's been really amazing. So some of the examples of backend functions or services we've used. We have a WhatsApp bot that's communicating with patients. That's deployed on as a Cloud Run service. Our front end, we've got a patient screening tool deployed on the front end. So that's when the patients are waiting in the queue to see a nurse. We have them filling in a little questionnaire so long. It has 20 questions. And by the time they see the nurse has access to all of the questions they've answered. And there's a bit of triaging that can happen already. The second one we're working on is a patient feedback tool. So that's just to gather feedback from patients all across the country. Like I said, we have 280 settings. Not every setting is perfect. Not every patient is handled perfectly, and we need to know where and when patients have grievances to raise. So these two are deployed as front-end jobs. Cool. So what have we learned along the way? Well, data form is crucial. So governance, lineage, and metadata, like I said, the unsexy things is really, really, really important. So I think us as a team underestimated the importance of tracking our data. You know, you think, oh, I'll remember the SQL, I'll remember what I did, and then 25 prepared layers later, no one knows what's going on. So metadata management and data cataloging is really important. Data quality is a non-negotiable. I think there's nothing worse than deploying a dashboard and then having someone question the numbers you're presenting. So data quality is super, super, super important, and data form allows us to assert our data quality rules. Cool, then, yeah, we've learned that Looker is a little bit limited. It's not the greatest visualization tool. Access management has been a bit of a pain point for us with Looker. You can only share these dashboards with Google accounts, and unfortunately, a lot of companies are still using Microsoft. So this has been a bit of a pain point with Looker. And then, of course, adoption hurdles. So many people are unfamiliar with the tool. They just haven't seen it before, haven't worked with it. They want Power BI or they want Tableau is often something we hear. But like I said, I think Google is working on this. And it is one of the things we've learned so far in our journey. Cool. So I promised that Hamza is going to look at the future, some of the stuff we're doing in Gen AI. So take it away.
Sure. Thanks very much, Ulrich. So far, we've discussed a lot about the features of our platform, the rationale behind the choices that we made. But the thing we want to know is, where's the chatbot? Where is Gen AI? And at this point, Gen AI is generally synonymous with the use of large language models, which is exciting technology. But going back to all of the considerations that Ulrich mentioned, we always need to think to ourselves, what are the unique considerations that we have to keep in mind before we decide to implement this technology? So within our context and limitations, some of the factors that we are always considering is going to be privacy. Where the data is stored, is the data being used for training or tuning? Should we be sending transcripts of patient notes to different companies all over the world? These are questions you always need to be asking whenever you get offered a new product. The second thing is cost. Again, there are many options, cloud GPUs and CPUs, but depending on what budget you're working with, you have to adjust. Another thing is speed requirements. If you're doing an implementation of an LLM and you want a user-facing live chatbot, that's going to be much faster than a back-end classification that you're running on maybe a cloud scheduler job. Also, the complexity of the task. So even though LLMs can do very complex tasks, they can also do very simple tasks. And you're always weighing up the options. You're like, do I need a high-end model to do something very complex, which could be wrong, or do I need a simple model to do something very simple? Another thing that you're always weighing up is, do we have the in-house skills to actually evaluate this? So let's say if you are asking it to do like a medical, to classify the accuracy of a medical diagnosis, if you don't have anyone in-house that can actually make that assessment themselves, it's really hard to evaluate whether or not it's doing what you think it's doing. This goes to my other point about evaluation. Do you have a gold standard for what you think this implementation should be? And again, this highlights the need for domain-specific knowledge. The final point I'm going to mention is language barriers. So even though models are continually expanding their capabilities, African languages tend to still be underserved within our context. Go to the next. So just talking about the different ways in which we've been thinking about hosting and deploying these models in practice. So here we mainly explored two main approaches which were available to us and easily expandable to our stack. So it's Google's AI, Google's model garden through AI endpoints, through Vertex AI endpoints, or Ollama, Dockerized Ollama. So the Google Model Garden provides enterprise-ready models. It's hosted on a Vertex AI endpoint, so it's easily deployed. It's natively integrated to the GCP platform, and it's fast. Ollama is a lightweight framework in which you can host open-weight models on your local machine. But they also offer a Dockerized version, so you can build Docker containers, you can pull the model weights, and then you can actually host this model within the Docker container. And this can be run on Cloud Run. So this is much more flexible. It's cheaper because we only pay for the compute when the container is running. So always when you're thinking about model deployment, you are basically weighing these different trade-offs. Complexity of how much work is it going to take you to deploy, how fast you need it to be, the cost, and privacy. So since we've been discussing the different deployment options, the next question is, what does the future of this Unjani platform look like? And what I've listed there is not necessarily the features, but what we believe are the non-negotiable requirements for future development. Again, we've been saying it over and over again, it's privacy first. Second, cost optimization. Third, the backend functions should be modular, so you can easily swap it in and out. And fourth, evaluations. Evaluations should be something that you can do easily. And so when we are always focusing on these foundations, then the impact that we can have can be either on the front end or the back end. So I will be talking about some use cases, just some pilots, some explorations that we are doing. The first one is going to be a back-end implementation. So that will be something that Ulrich mentioned earlier, the emergency case flagger. And the second thing is going to be something we're still working on, which is generating patient summaries for nurses. And this would be a front-end implementation. So basically, this slide, we just want to talk about how we are deploying these use cases. So we use a open-weight small LLM. It's MedGemma. It's the 4 billion parameter one, so it can fit within a small Docker container. And this is hosted on Cloud Run. The two use cases that I'm going to talk about, it's going to be the patient history summarizer, which will be front-end facing, and the emergency flagger, which will be back-end facing. The rationale behind deploying these implementations in this way is, again, because it's easily integrated into our stack. We control the privacy, and at least for the emergency flag, it's not user-facing, so speed is not a requirement at this point. So next slide. So here's just some screenshots of some of the experiments that we were doing. So this is the first use case. So this is how we might generate patient histories. This is just some example text that I did. You might see at the bottom there, it doesn't look like bad doctor's handwriting, but that is actually what it looks like if you type it. So the prompt is what you're going to send. The input is what is going to be sent with the prompt, and this is what the output would look like. So basically, we're still experimenting with how we would implement this into our backend, but this is just a simple way of taking unstructured backend data and turning it into a more meaningful, structured output. This is something that we can run on our lightweight stack. Speed is not critical for this. So on our mainly free platform, this is how we can implement an LLM that is open weight. So you're not going to, so you control the privacy, you control the compute, and you can, if you understand the output, then you can evaluate exactly what you're doing. A second use case. Oh, okay. I was actually explaining it the opposite way. Yeah. Yeah, so this is the emergency flagger. So this would be if you have a consultation note, we will be processing this in the back. We'll be running this on Cloud Run, and then we will ask the LLM, is this an emergency that should be checked up on later? You can just go to the next slide. So here is just some screenshots of what this is going to look like in terms of the Cloud Run deployment. So there's our container running there. We have some screenshots of the memory and the CPU and the request latency. Again, because this is just experimentation, you can see that it's not very active right now, but however, just in terms of demonstrating that this is how you would be implementing an LLM on a lightweight stack, this is what we can do. Sure, thank you. Any questions and discussions at this point?
Any questions from the audience?
Hey, Craig.
Yeah.
Hold on a second.
And so what we'll do is, just for the purpose of the guys, when they ask a question, you can always repeat it. But yeah.
Okay. Cool.
Just quickly.
Thank you. Well, firstly, hi, Jordan. Nice to meet you.
Cool, nice to
Thanks
meet
for
you.
a cool talk. I've got a question around data in test environments. So I know in my project, we've got an enormous amount of public data, and it obviously needs to be protected in various ways. Do you guys have like an internal and a QA environment where you would have that data, or at least subsets of that data, replicated and anonymized in order to sort of protect the privacy?
Yes, Josh. So we have a dev staging and prod environment. We do have a sandbox to play in. Yeah.
Okay, very cool. And then my next question, with the version controlling that you mentioned, is that around like if an insight is sort of processed and sent to someone, you need to sort of track that back to what could have given that? Is that, am I understanding that?
Yeah, so I think version control at all levels. So I think version control in code, firstly, that's like the foundation of everything, but also in your data, right? So we need to know exactly which data created which prepared layer and which was linked to a specific Docker container that produced the insight. So it's right the way through the pipeline.
Okay, well, that's very cool. I had never considered that as like a version controlling like use case. Yeah, very cool. Thank you.
Yeah, sure. More questions?
Thank you. That's a pretty interesting presentation. My question is just on the ICD-10 codes. Yeah, the microphone to the doctor. So I know that it's quite it's large. It's a lot of data. And with regards to MRI, there's still a lot of research that needs to be done, especially with like osteoarthritis, for instance. And we have specialists that are only available in Sweden or in the UK and very limited in South Africa. So in terms of codes, do you program that within the model, and do you protect that data, or do you de-identify the data for a specific patient and then store that into like a query or database to use at a later stage if you come across another patient that has similar ailments, in order to create a prognosis for that specific user?
So that's a great question. So what we are actually finding is our ICD-10 coding system actually does need a bit of advancement. So this is actually what I was mentioning earlier about inconsistent adoption of standards. So right now we are not training a model to code the ICD-10 code thing. We're still relying on clinician-provided ICD-10 codes. These, so the thing about our client is that they're all nursing providers. So it's going to be basic primary healthcare ICD-10 codes. So it's not going to be any more advanced than general basic checkup, lower back pain, hypertension, things like that. So at this point, we are still relying on clinician-provided ICD-10 codes. But I think there is a lot of opportunity for us to actually automate it and check it. However, you mentioned that ICD-10 codes should be a way of kind of describing a patient. I think that is an important development, but I think we also, at least within our patient profile, I think you need a typical patient first to be presented as a golden standard of, oh, this is what a hypertensive patient would look like, or this is what a lower back pain patient should look like. And then that can kind of be mapped as the gold standard. And that still needs to be built up yet. So we are still in the stages of doing that. But that is a very interesting development. Yeah.
Thank you. You have a question? Sure.
Hello. So I heard throughout the presentation that privacy is very, very important. I would like to hear your strategy as to how you will maintain the privacy of each of those patients that will be using this platform.
Each of the patients represented in the platform. So, of course, all data moving is encrypted right throughout. Everything is de-identified. Anything leaving the actual DB in the EHR is de-identified. It wouldn't be able to leave the EHR if it's not leaving safely. Let's put it that way. Not sure if that's answering the question. Of course, none of this analytics is public. Nothing is publicly available. It's all protected. Yeah. Do you have another question? A further question?
Do you want to follow up with the question?
Yes, because I'm thinking, let's say you introduce this into the clinic, then you encounter people that are skeptical of using this because they're not sure how they are protected. There's no way of understanding. I mean, for me as a program, I would understand when you say it like that, but for another patient, they'll be like, oh, what exactly, why do I have to say this to this? How do I know that this is going to work for me as a patient here and that no one is going to know my private information? I don't know if you get me.
Sorry, I have a question. Can I comment on
Yeah, please comment.
So I'm not a developer. Just put that out there. Not a developer. I'm in preventative health. So for me, answering that question, it would be the responsibility of the clinician, because you go from paperless to online. And so it's the importance of clinician, because whether it's on paper or whether it is on a computer or on a tablet, it's their responsibility to remain that privacy, because it's a consultation. So there is a people component involved that needs to be explained in that. And so I think that's the first and foremost, for them to explain that we are moving over. And so that's the clinician's responsibility with regards to that, and then for them to protect the data that's out there. But my question is in terms of, I hope that answers okay. Just in terms of being, I would be the end user in this case, and for me, I just want to understand what is the outcome or the output that Unjani Clinic wants to. Is it to make it easier process? Is it to because what I'm thinking is that with that, because there's like what 600 clinics that they're wanting to, and even us moving into NHI, it can only happen if there is more preventative models out there, because we don't have the infrastructure in terms of healthcare. And so is this data being used to identify communicable and non-communicable diseases in that sense, and also in terms of putting prevention measures and possibly referrals between government, because in the different provinces, they refer, I mean, I'm assuming, I've only been in the Western Cape, they refer to the clinics and the NPOs in that regard. And I know there's a lot to do, because the referrals process is, yeah.
Yeah, I think you asked a couple of questions that are related. So the first one is preventative methods for preventative medicine, protecting patients early on, identifying at-risk patients. So that is something that we are working on, but it also depends on how data is collected at the first point of care. And this is actually going back to what you were saying. So at any point in time, a patient that is engaging with the system is a data subject. So they own their data, they protect their data, they choose what we can do and what we cannot do with their data. And it is actually the responsibility of the clinician who is taking that information from them to make sure that they understand what they're consenting for. And what they're consenting for has to be something that we can legally process, even for something like a machine learning preventative, a machine learning algorithm for identifying at-risk patients. One thing, going back to what you're saying about the NHI thing, is that the Unjani system has got a huge patient population. How many?
2 million.
Yeah, there are 2 million patients. So it is in some way kind of representative of the population of South Africa. However, there is definitely a socioeconomic element to it, because this is still a paid service. So we are hoping that in some way this can, at a later stage, serve as a model for what an integrated digital healthcare system could be. But for that to be the case, data quality needs to be improved. It's very hard to make inference. It's very hard to draw insights if you aren't sure exactly that your data is saying what you think it's saying. I think you had a third question.
And I mean, it's fine.
Okay.
And just in terms of what you guys are building, is it specifically to, because I'm also work with an NPO that does like free dental outreach, or is this available to other organizations or NPOs, because this is very much needed in the healthcare sector, specifically with regards to NPOs that are assisting government reach the community-based and grassroots. So is it available? I mean, like how, where to from now, and what else are you guys doing?
This platform.
Cool. Yeah, definitely. I mean, Unjani Clinics is not our only client. It's the subject of today's talk. It was a really good example. But we have worked with other non-profit organizations as well. And yeah, it definitely is a replicable solution. It is something we can replicate. It was built like that. It was built in a way that it can be lifted and shifted to other organizations. That was a lot of the design decisions around what we did was exactly for that. Because we also know in healthcare sector, there's not necessarily millions and millions and millions to be thrown around. So we do want to build in a way where we can, every time we build it, we can go faster and faster and faster. So maybe scan the QR code on the second slide.